Welcome to the first highlight video for our math class. This video is not a summary about rounding, nor is it a most important parts of rounding. Rather, it helps you make connections. Why are we looking at rounding, and how will it fit into later parts of the class? Because of this, if you are watching this immediately after the rounding section is done, our first section of the class, it will talk about things in the future we haven't looked at yet. It might be helpful to have an overture of what is coming up in the class, or it might just be too confusing at this point, and you should watch this video later on. In any case, we start by talking about rounding, and there were two subtopics: decimal accuracy and estimating. Why do we care? For decimal accuracy, we started by noting that some decimals are indeed very accurate. But then we talked more about when there is fake accuracy. Things are too accurate when we do the problem. We looked at 3 problems that involved 40 divided by 7 that had context. What types of measurement devices were there that would tell us how much to round? Our party favor bags, a pharmacist's scale, and a carpenter's saw different as far as rounding. We also talked about a general rule for accuracy. Often in a math class, you're just given a homework problem, and there's no word problem that says what's happening. There's no description of what's the context. We don't know what measurement devices are being used, so we can't use our kind of real-life intuition about how accurate things should be. So the general rule is that when we need to round at the end, use the same number of decimal places as the problem's original values had, or perhaps add one more. So far, so good. We also talked about estimating, the fact that estimating changes the answer. Rounding in the beginning of a problem messes up the math, but it is often unavoidable in real life. Later in the term, we'll get to the big issues without real answers. And real-life problems like these involve a lot of estimating. If you're using some health formulas, then your weight won't be the same from day to day. If you are planning a vacation, then vacation costs differ. The price of gas will be different at each gas station. The price of your motel or hotel will change each night. If you're renting a house or buying a house, then your utilities won't be the same from month to month often, and so on. So we just have to pick numbers that represent the situation as best we can. We are forced to estimate. So that's why we talked about estimating in the rounding section. And another important part about rounding was the difference between tens and tenths. Here we had 7 being our tens place and 5 being our tenths place. And that th is important. Similarly, thousands and thousandths. We care about that because when we get to percent format, we'll have these decimal point scoop patterns. And the patterns are much easier to understand if you keep in mind the difference between tens and tenths, hundreds and hundredths, thousands and thousandths. So pointing out the th in the names of the decimal point place values is important. Finally, we talked about place value because it's nice to think about tens and tenths as a times 10 or a times 1/10. Or for hundreds and hundredths as a times 100 and a divided by 100. We use that a lot in percent format. When we started the 4 replacements for percent symbol, there was this very important chart. if I have 47%, I can write that in 4 ways. Percent means out of 100. And out of 100, we could do divided by 100, take that percent symbol away and replace it by something that means the same thing. We could also replace it with 2 decimal point scoots to the left. We could replace it by 47 hundredths. And we can replace it by 47 times 1 over 100. And understanding place value helped us see that divided by 100 and hundredths and the place value of hundredths are all exactly the same thing.